Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on analytical dynamics or classical mechanics chapter variational principle, lecture number 4, in which I will solve problems on Hamilton's principle. Now we solve a problem. Problem is, prove that in the case of a particle moving in xy plane under a central acceleration n square r, the value of Hamilton's principal function s is n by 2 sine n2 bracket x square plus y square plus x prime square plus y prime square bracket closed cos n2 minus 2 bracket x prime plus y prime bracket closed, where tau equal to t minus t prime. Now we solve this, since given that central acceleration acts on the particle is n square r. This is the central acceleration acts on the particle and its direction is toward the origin O. Therefore, equation of the particle is acceleration d2r by dt square equal to minus n square r. Let this is number 1. Let us assume that the mass of the particle is unity. Therefore, central force equal to central acceleration. Therefore, potential energy equal to negative of work done to bring the particle at the standard position. Therefore, potential energy V equal to negative of central acceleration, means central force, is minus n square r dr. This is equal to minus minus plus n square, integration of r is r square by 2. Let this is number 2. In Cartesian system, the equation of motion will be d2x by dt square equal to minus n square x, since component of n square r means minus n square r, this acts towards the origin O and its component along x axis is minus n square r cos theta, and r cos theta equal to x, that is minus n square x, and d2y by dt square equal to minus n square y, implies that d2x by dt square plus n square x equal to 0 and d2y by dt square plus n square y equal to 0. This is number 3 and this is number 4. Since equation 3 and 4 are equations of simple harmonic motion, therefore solutions may be written as x equal to a cos nt plus epsilon and y equal to b cos nt plus epsilon prime. Let this is number 5, this is number 6. Implies that x dot equal to a derivative of cos is minus sign, minus here n sin nt plus epsilon and y dot equal to b, here n, this is minus sin nt plus epsilon. Since kinetic energy T equal to half, we have assumed mass 1, mass into velocity square, x dot square plus y dot square. This is number 9. From 2, potential energy V equal to n square multiply r square equal to x square plus y square by 2. This is n square by 2 x square plus y square. This is number 10. Since Hamilton's principal function S equal to integration limit 0 to 2 L dt equal to limit 0 to 2 L means t minus v dt. This is equal to integration limit 0 to 2 t is half x dot square plus y dot square. If we take common half, here v is half n square under bracket x square plus y square minus n square x square plus y square bracket close dt. Let this is number 11. Implies that S equal to S be the Hamilton's principal function equal to right side in place of x dot square we write the value from 7, and in place of y dot square we write the value of 8 here, and minus n square, here x square we write the value from 5, and plus y square we write the value from 6 here. Here we take common minus n square by 2 outside, and we write first this a square, take common, remains cos square nt plus epsilon, and here remains, as we have taken minus common, so here will be minus sine square nt plus epsilon. Similarly, here we take b square common, so remains cos square nt plus epsilon minus here sine square nt plus epsilon. Here this equal to minus n square by 2, integration limit 0 to 2. Here cos square theta minus sine square theta is cos 2 theta, that means cos 2 nt plus epsilon. Similarly here cos 2 nt plus epsilon and integration. Now we integrate this. Here remain a square, integration of cos is sine, and coefficient 2n is as a denominator. Here same, integration cos is sine and coefficient 2n as denominator. Here limit 0 to 2, here limit 0 to 2, implies that s equal to minus n square by 2, here a square bracket, formula of sine 2 theta is 2 sine theta into cos theta, we expand this here, 2 sine nt plus epsilon cos nt plus epsilon by 2n, here limit 0 to 2 plus b square. Here also we expand this term by the formula sine 2 theta equal to 2 sine theta into cos theta, that means here 2 sine nt plus epsilon dash cos nt plus epsilon dash by 2n, limit 0 to 2, equal to, we take a square outside, so in outside minus n a square by 2, we use the limit firstly 2, so this will be the term by putting in place of t 2, then we use t equal to 0. If here t equal to 0, then it remains sine epsilon, then cos epsilon, here t equal to 0. Similarly, we have used the limit in this term, firstly 2, then 0, and we will get the equation number 12. Now let this part is assumed as a equal to minus n a square by 2, this sine n2 plus epsilon cos n2, and here we divide by sine n2 and we multiply by sine n2 with each term. This equal to, here we expand this sine n2 plus epsilon, sine a plus b is sine a into cos b plus cos a into sine b, and multiply cos n2 plus epsilon minus sine n2 sine epsilon cos epsilon, implies that a equal to, here we write minus n is Na square 2 sine n2, and we multiply the terms under bracket by n2, and we will get this term up to this term, and remaining term minus sine n2 sine epsilon cos epsilon. This equal to, we write this term here outside, and value of sine square theta equal to 1 minus cos square theta. Here we use this formula, and we write the other remaining terms. Same. Equal to, we write the terms outside the bracket, this, and we multiply this with these terms, and we will get this term plus this term minus this remaining term. Implies that A equal to minus Na square by 2 sine n2. Here we write the same thing, minus, we take common cos n2, multiply cos n2 plus epsilon from this and this term. Then remains under bracket cos n2 cos epsilon minus sine n2 sine epsilon, and last term be same. Here we write this term outside the bracket same, here this term same, minus here cos A into cos B minus sin A into sin B, means cos A plus B, means cos n2 plus epsilon. In this place we write this, minus here only we have term sin n2 sin epsilon cos epsilon. So for this we write here cos n2 cos epsilon and multiply cos epsilon, and here we write minus cos n2 plus epsilon. If we expand this, we will get minus cos n2 into cos epsilon, this cancel out, remains here plus sin n2 sin epsilon and multiply cos epsilon, same thing. For this we have written these terms under the bracket, and equal to this term outside the bracket same, this term same, and now multiplication of these two terms is square, cos square n2 plus epsilon, and here we multiply cos n2 cos square epsilon, cos epsilon multiply cos epsilon, then we write minus minus plus cos n2 plus epsilon multiply cos epsilon. Here we multiply the bracket by this negative, so negative terms will be positive term and positive terms will be negative term. So under bracket first we write this term and this term, positive term, and here this term and this term be same, so we write 2 cos alpha cos n2 plus epsilon and with negative sign. This is number 13. Let x prime equal to value of x when time t is 0 and y prime is the value of y when time t equal to 0. X will be the value of x when time t will be tau, and value of y will be y when time t will be tau. Let this is Equation number 14. Since x equal to a cos nt plus epsilon and y equal to b cos nt plus epsilon prime. Now putting t equal to 0, here x equal to x prime, t equal to 0, we get a cos epsilon. Here for t equal to 0, here y prime equal to b cos, here 0, cos epsilon prime. Similarly, putting t equal to tau, x equal to t equal to tau, x equal to a cos n tau plus epsilon. Similarly, y equal to b cos n tau plus epsilon prime. Using these values in 13, here we get n by 2 n tau. Here we write a square cos square n tau plus epsilon means x square and remains cos n tau. Similarly, here a square cos square epsilon means x prime square and remains cos n tau, minus here a square enter here, a cos n tau plus epsilon and multiply a cos epsilon, that means x multiply x prime. So minus 2x multiply x prime. Here we take common cos n tau and remains x square plus x prime square minus 2x x prime. This is the value of a. This is equation number 15. Similarly, second part of 12 will be b equal to n by 2 sin n tau. In place of x we will get y square plus y prime square cos n tau minus 2y y prime. This is number 16. Using 15 and 16 in 12 we get s equal to n by 2 sin n tau. This is the value of a and this is the value of b from 16, and we take common n by 2 sin n tau. Here remains x square plus x prime square, here y square plus y prime square, and common is n tau, minus we take common minus 2 x prime plus y prime, and the problem is proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.